If you're doing a bachelor thesis right now, you have to watch this video. Last time, as we progressed through the topic around data collection, now we focus on the next topic, the data preparation. Data preparation is the process on which you take the collected data you have and prepare it for the analysis. It's not like the analysis itself, it's like the work you have to do in order to use your software and to get to good results. The first path you have to take is the one where you translate your data into a numeric format or into a qualitative counting format. So what do I mean? I call this part translation. In this path, first you go into the data and translate everything you have in a qualitative way or in a more speaking way into a numeric value. This is done very easily. So let's say you have a Likert scale from agree to disagree, and you have to assign every answer pattern, every answer a numeric value. For example, 1 to 5. This is common in Likert scales, but it's also common if you are trying to analyze groups. So if you have qualitative data, let's say gender, this also has to be translated into 1 or 2 or 1 or 0. So these translational work, most of the data collection tools you have already translate your data into numeric values. In some cases, you have to do this manually yourself, but the translation work is one of the first things you have to do in order to get your data correctly. After the translation, we have to clean our data. So we have the translational work, and after that, we have the data cleaning. And the data cleaning is where most of the mistakes happen, because this is not easy to do. And we will go through the most important data cleaning steps you have to take in order to have a clean data set, most important ones in which failures you can have. So first of all, we have a data format, and the data format decides how your data will look if you're looking into the data set itself. So for example, if we pick an Excel file, XLSX is the most common one, but besides the Excel files, we can have like CSV files, we can have TXT files, and there are different formats which are less common. And in this case, there can be some mistakes inside of these files. You have to know exist, because otherwise you will have big problems later on if you try to get your data into the analysis programs like SPSS data and so on. First of all, there is a convention on your PC on which is the decimal difference. So for example, if we have the American way, it's 1.52, would be an American number, but in Germany, this wouldn't be a number. So in Germany, we separate our decimal numbers with a comma, not with a point. This is the first difference which can occur when you try to load your data into the program on which you have to look how the data is formatted. The second thing where some mistakes can happen is that there are delimiter signs which separate the columns from each other. So for example, we have 3 columns. They can be separated by semicolon, by comma, even space can be the separation, the delimiters of the separation between the columns. And sometimes there are mistakes because of this, what I mentioned, because when you have a programmed with a German convention on the decimals, for example with 3.6, then the program, then your analysis program could interpret this number as 2 numbers. This is one of the big things where you have to look out for when you try to get the right data format and try to load your data into your analysis program. The second thing is the identification of valid datasets. A valid dataset is first and foremost defined by you. Before you go into the analysis, you have to be sure on what you say. This counts as a valid dataset for my analysis or for my thesis, and this I will discard. These answers, these people, these trials, I will not look at, so I will not analyze them. And as I mentioned in a previous video, we have like a target sample. So we have a population which we want to analyze, and we have sometimes people we do not want to look at. For example, if we say we only want to look at people below the age of 35, then people who are older than 35, we have to discard for our analysis. Otherwise, we will get to the wrong or to a distorted conclusion in that regard. Another one is sometimes we have people who are not very conscientious when they do our trials or fill out our surveys. Sometimes called speeders, so they go through this survey in 30 seconds. And if you would read every question, it's impossible to go through this in 30 seconds. So this is also something very common. Even if you do a survey in your close family or with close friends, there will be people who will not really answer your survey or will just speed through this. Besides the speeders, you will have people who will not pay attention to the questions you're asking. So they will just take the first answer and they think they are finished. To prevent people for this, so they will always take the first answer, for example. There you can build in some verification question within the questionnaire itself. This can be a little math problem like here, but this can also be a question for: did you pay attention while questioning this, while answering the survey, or did you answer the questionnaire truthfully? Right? So there are different types of how you can do it. I think a very elegant way is like this little math problem, where with 2 or 3 or 5 obviously wrong answers. So in the case like this, what is 5 plus 7 minus 3? It's 9. So we can say, okay, this is the correct answer. So people who answer the wrong question are automatically excluded for your analysis. When we are talking about valid datasets, we also have to talk about dropouts and missing data. First, we look at the dropouts. What is a dropout? Dropout is a person who did not finish your research, who did not finish your survey, your questionnaire, or whatever you are doing with them. They are in online format a rather normal occurrence, so it's like, so for 30 to 50% do not, of all people who click on your link for the questionnaire or similar, will not finish the whole questionnaire or the whole survey. So this is a rather normal occurrence. And normally people who do not finish the questionnaire are taken out, or are deleted from or are discarded for the analysis. So we do not look at people who drop out. In this graph, I have 3 dropouts for our dataset. We'll usually see in every form of questionnaire, survey, research are missing data. And missing data is more of a hot item in this regard, because there's a big discussion whether you can delete people who have missing data, or you can keep them and just exclude them in the variables where they didn't answer. The challenge here is we cannot know why they didn't answer your question or why the data is missing. So nonetheless, we have to find a way how we solve this problem. So in this data set here, we have 1, 2 missing data in this data set. And usually there are the 2 paths we can take here. The first path is that we say, or we just imputate, we just fill in the missing data. So we take the average of the column and we fill in the average in the missing data. Then we do not distort our data and we still can provide a full data set. On the other hand, we do not want to know what the people would have answered in real life. So the second path we can take is we just delete the datasets with missing data fully. I previously described that you have to translate the data sometimes from words into numbers, and you have to numerize your data. And the second translation we have to do, look which variables do you really need for your analysis and choose. For example, I translate this variable into age, and this is something I have in my hypothesis, so I keep this in my analysis dataset. On a difference occurrence, you have to know, sometimes you have several questions which are part of a bigger construct. For example, we have Netflix usage as a biggest construct, and Netflix usage can be built by 3 variables on the left. So these ones we want to obviously keep in our dataset too. And there are some other data, for example, timestamp, or there are some other data we can discard because we do not need them in the analysis itself. When we're talking about renaming the data, sometimes in some data collection tools, you will get 2 header rows. So we have to delete one of the 2 headers. In our case, we want to keep the names of the variables and we can rename them in a sense. As we progress through the data preparation, we now know what our variable is. We have cleaned our data from missing and from dropouts. We have validated who we want to keep and who we do not want to keep. And now we have to create the variables we cannot measure directly. So for example, if we variables which can be put together for Netflix usage, we have to decide, do we want to sum them up? We want to the average of the answers. Do we want to do a different transformation? So there we have to decide how we want to do our scale building. So these are the most common ones, but there are many different types of scales you can build. One of the biggest mistakes students usually make here is that they do not check whether the questions they are using or the metrics they are using are going in the same direction. For example, if I have a question which is like, how much do you like Netflix? And you have to say whether you agree or disagree, then you can say, yes, I love Netflix very much. And if you have in the similar construct, so V2 in this case, so this here, I hate Netflix, and you say, I agree here too, so like here, then you will have conflicting data. So you have to look whether this and this goes into a pattern where it makes sense. So if people say I love Netflix, it should be like this, and if people say they hate Netflix, it should go down here. And every question should have a logical, topic-related order which go into the same direction. So if they're not in the same direction, what do you have to do? You have to transform your data patterns. You have to give the biggest data, for example, it's like the 4. You have to transform the biggest data into the lowest data point. This is very good possible in Likert scales. If you have other type of data, it can be a little bit trickier, but for Likert scales, it's rather easy to do. Now we have the names. We know what variables we need. We have our cleaned data. Now this is the first part of the data preparation finished. If you follow these steps, you will have a clean data set and you can start the analysis. And want to know which method you can use to analyze your data, comment below, check out our helping assets, and we will see you in the next video.